It always half the time it catches me. For some reason, when it starts recording, camera zooms way back. Kind of an irritating thing. I usually remember to anticipate. I didn't this time. Okay, so 5x plus 7 equals 3. You subtract 7 from both sides. Alternatively, you can add the equation -7 equals -7. Okay, so you have two ways to write this step. Okay, the other way, you write 5x plus 7 minus 3 equals 3 minus 3. Okay, you just subtract 3 here, and you don't want to subtract 3, you want to subtract 7. Okay, so you subtract 7 from both sides. It's going to accomplish the same thing as adding the equation -7 equals -7. Either way, follows the rules. You can add the same thing to both sides. In this case, we added a -7 to both sides. Okay, in this case, we added two equations. We made up an equation here that'll eliminate 7. Okay, and these are both good ways to do it. And you should understand both, because you're going to see both. Well, anyhow, if we add the two equations, we get 5x equals -4. So we get x equals -4/5. And then we can check that out. It's a pretty simple equation. We can kind of do this in our head. If x is -4/5, then 5 times x is 5 times -4/5, and that's -4. If you add -4 to 7, you're going to get 3. Okay. Now, did you get -4/5? Thumbs up if you did. Yep. Okay. And over here, comes out exactly the same. If we do this step, 7 minus 7 is 0. That leaves us 5x. 3 minus 7 is -4. So doing it this way, doing it this way are absolutely equivalent. When you finish it in the same number of steps, you're going to have this. So there's no real advantage to one over the other. But again, you should know it both ways. Okay. Now I'll just put it center down here. Because it works. And here we're doing, okay, we start by we have two equations. Okay, here we add -7 both sides. Well, here, and you kind of prefer this. So next one I'll do this way. Just remember, be able to write it out this way if you need to. Okay. So we got 3 times 4x minus 9 is 5 times 2x plus 6. That gives us 12x minus 27 equals 10x. Plus 30 by the distributive law. Specifically, the distributive law of multiplication over addition. But who wants to write all that out? Okay, as long as we understand that the distributive law distributes multiplication over addition, doesn't distribute exponentiation over addition. Okay. Just multiplication over addition. Okay, so we have this, and then various ways we can do this. If you want to really shortcut it, you can add a -10x plus 27 to both sides. And in one step, you will have all your x's on this side and all your numbers on the other. So you get 2x equals 57. And x equals 57 halves. I think that's what I saw in your paper. Okay. What we did here. I added a well-chosen equation. Okay. I chose it to eliminate the 10x over here and to eliminate the negative 27 over here. So I'd have the form that makes it easy to write out the solution. Okay. Now on this one, the general thing you want to do, I think maybe I talked about this before, because we were kind of probing, what people do and so forth. But we have denominators, and denominators are a royal pain in the neck. So if we get rid of denominators in an equation at the very beginning, makes the equation much simpler. Okay, so what we do is multiply by common denominator. Common denominator is x, so we multiply x times 5 over x plus 6. And that equals x times 7 over x. Well, x times 5x over 6 by the distributive law is x over 1 times 5 over x plus x times 6, which is the same as 6 times x. That equals x over 1 times 7 over x. Well, this is the same as x over x times 5 over 1 plus 6x equals x over x times 7 over 1. Because either way, you have a numerator of 5x here, like you have it here, and you have a denominator of 1x, or just x. And over here, your numerator is 7x, just as it would be here if you multiplied this out, and it's 1x here, but x over x is 1. So I'll go ahead and draw a line through it, but I'll just say, okay, this is 1. And this x over x is 1. So we get 5 plus 6x equals 7. And the rest is really easy. Okay. We get x equals 6. Give you a minute to process that. Okay, now I'm not sure that all this was visible. Just to review this real quickly. 5 over x plus 6 equals 7 over x. We can multiply by the common denominator, which is x. And we go through the process. X multiplied by 5 over x plus 6 is x times 5 over x, which I write as x over 1 times 5 over x, for reasons you can see. And x times 6 is 6x. X times 7 over x, well, we see write that as x over 1 times 7 over x. Then we can rearrange the multiplication. X over 1 times 5 over x is the same as x over x times 5 over 1, because the numerator is 5x, the denominator is x in this case. And in this case, the numerator is still 5x, the denominator is still x. So it makes no difference. Having written it this way, with x over x, we know that x over x is 1, unless x is 0. So when you multiply by common denominator, you gotta be careful that you multiply by a non-zero common denominator. We'll worry about that a little more later. Okay. And then over here with the x over x times 7 over 1, same thing happens. We end up with 5 plus 6x equals 7. Then I say, okay, then the solution 1/3. Well, I subtracted 6 and 7 instead of 5. Okay. So I just carelessly did that in my head and didn't check it, but I'm gonna check it. Okay. I got 1/6. I got corrected. Okay. Last worked it out in detail. You got 1/3. And obviously, if you subtract 5 from the 7, which is what I should have done, you're going to get 2 over 6, which is 1/3. Okay, so now it's about, I wrote it out as 1/6 the solution of this. Okay, well, turns out that 1/6 wasn't going to be a solution of this. And had I checked it, then I would have recognized that I'd made an error and I'd have gone back there and done that step more carefully. Okay. So let's go through the check. Okay, well, I'm going to let you write out the check. See what happens if you write out the check, because this gets into complex fractions a little bit. And that's something we might need to talk about. Okay, well, very quickly, let's go to check, and it looks like a good check. Wrote out 5 over 1/3 plus 6 equals 7 over 1/3. Then said, well, okay, that's 5 times 3. And that's 7 times 3, so we get 21 equals 21. And it checks. Now the question is, that's right. And let's make sure we understand why 5 over 1/3 is 5 times 3. Okay. We have that reflex. We know that. Let's make sure we understand it. Yeah, well, why is 5 over 1/3 equal to 5 times 3? Well, it's because 5 over 1/3 is 5 divided by 1/3. When you divide by a fraction, you multiply by its reciprocal. And there's a simple reason for that. How many 1/3 are there in 5? Okay, well, talk about that. Go ahead and everybody process that for a minute. Okay, well, clearly we know that's what everybody did. Why 5 divided by 1/3 is 5 times 3. What do we mean when we divide 5 by 1/3? That means how many 1/3 are there in 5, right? You divide 10 by 2, result is 5, right? Because 2, 4, 6, 8, 10. 5 2's make 10. Okay. Why is 11 divided by 2 5.5? Well, because you get 2, 4, 6, 8, 10. 5 2's is 10. You still need 1, which is half of 2. Okay. So you really want to understand the numbers that way. If you want to count the 5 by 1/3, I'm going to do that in the number line. Okay. Where's 1/3? Well, there's 1/3. So I'm dividing each of these intervals into 3 presumably equal parts. They're supposed to be equal. They're not exactly. And let's make sure that I can see what I'm writing in the can. So move this over a little bit. How's that? Let's still go a little further, even a little further. There we are. Okay. So Here's 5. And each of these is 1/3. Well, there are 3 of these in each 1 unit interval, and there are 5 1 unit intervals. So we have 5 1 unit intervals, each divided into 3 parts. So there are 15. Those parts. Each part is 1/3. So our conclusion are 15 1/3 and 5, right? Okay. Now you can go on with that, but that's the fundamental idea behind flipping fractions when they're in the denominator. Okay, they can extend that idea. But the other reason is also 5 divided by 1/3 is 15. Because 1/3 15 is 3. 10 over 2 is 5. 10 divided by 2 is 5, because 2 5s is 10. Okay. So it's the reciprocal relationship between multiplication and division. It also tells you that the geometric picture is informative, and it's one you want to kind of keep in mind and even use occasionally. And the reciprocal relationship between multiplication and division. If this divided by this equals this, then this times this equals this. You know, I could write that out, but I think you have the idea. Okay, that's kind of an important thing to understand. You understand the arithmetic much better if you both know the rules, which everybody apparently does. Okay, and know why the rules are what they are. All right, so we got 5x minus 3 less than or equal to 12. We can treat the inequality just like an inequality with one exception. We can do the same steps. So we could add 3 to both sides. I'm going to write about this way. But you could add the equation that 3 equals 3 to this equation, and you're going to get the same result, and you did, which is 5x is less than or equal to 15. Then you can divide both sides by 5. And you get x less than or equal to 3. So I'm going to give you another one. See what you do with this one. Okay. So we rearrange this. Now I'm going to add. No, I'll add Negative 8x minus 7. And I'll add this to both sides, getting negative 5x equals 2. Not equals less than or equal. Okay. And I think that's going to be right. Okay. Now I want to divide by negative 5. Got negative 5x over negative 5 and 2 over negative 5. I divided by a negative, so I have to reverse the inequality. If I don't reverse the inequality, my solution is going to differ from yours, and I think yours is right. Okay. That gives us x is greater than or equal to negative 2/5. Is that what you got? Okay. Now what you did is you solve it like this. Added this equation to this inequality, and I got negative 2 less than or equal to 5x. You did this, okay? Divided both sides by 5. And I got x greater than or equal to negative 2/5. Or negative 2/5 less than or equal to x. Of course, negative 2/5 less than or equal to x is the same as x is greater than negative 2/5. Okay. If this is less than or equal to x, then x is greater than or equal to this. Visualize this. Well, you know how to graph that on a number line? I'll tell you out loud. You do. Okay. So I'm just going to do it. I trust you. And if this isn't what you were thinking, or very close to what you were thinking, because I'm not sure what textbook you use, but it's pretty much the same everywhere. Okay, so I've got a number line here. And I've got negative 2/5 right here. And the numbers that satisfy this equation include negative 2/5 and every number greater than negative 2/5, because this says x is greater than or equal to negative 2/5, right? Now, if we look at it this way, again, we've got negative 2/5 here. And negative 2/5 is less than or equal to x. Well, that's going to be true as long as x is on this side of negative 2/5. Because this is less than any number over here. Okay. So again, if I was to think about it this way, I'd get exactly the same graph, exactly the same numbers satisfy both. If any number that satisfies one of these satisfies the other. Okay, so totally equivalent. If I hadn't reversed the inequality here, when I divided by the negative, which is this step, right? This is where the inequality. I'm sorry, reverse inequality up here. Thought I lost my mind from that. Well, okay, did it. Okay. The inequality reversed between here and here because that's where I divided by the negative. The reason for that is just this is the same as this. Okay. Okay. First of all, the interval notation. There are a couple of ways of writing this interval. This could be expressed as the interval grammatically correct. I say this is the interval. I will say that any x that satisfies this is in the interval. -2/5 infinity. Okay. Includes -2/5. So I use a square bracket here. And it goes forever to the right, indicated by the arrow on the picture. And a formal statement of this is x satisfies this if and only if it's in there. But that's the interval notation. You've seen that, right? And I think it's familiar to most people who have who remember something from their algebra course. Okay, and since everybody here seems to remember a lot, I think we're pretty good with that idea. Let me check one more thing. I just kicked this thing again. I'm going to have to do something about that. Okay. Another way of writing this. Okay, we also express this. This is often a useful notation, and it's one of the harder things to understand. This is pretty easy to understand. This is pretty easy to understand. You haven't seen it, and I'll bet you have. But if you haven't seen it, set Euler notation. It's a set of f values such that, this line stands for such that, or you could say with the property that x is greater than or equal to -2/5. Now, the question is, later on in the course, and we could actually do it here, on one of the inequalities we had x in the denominator. If we have x in the denominator, it can't be 0. Because you can't count to anything by zeros. Okay, it just doesn't work. You can't define division by 0. So this would indicate the set of all x's that aren't 0. Now, the question is, on the number line, how would we indicate the set of all x's that aren't 0? And so here we have the number line. And here we have 0. Okay. So, ask how we might do this. The answer I got was, well, you're gonna have two arrows, that. And that's right. You have an arrow from here to here, and an arrow from here to here. Well, that kind of looks like the whole thing. How does that exclude zero? And even before I got to explain it, so I got the answer, well, you should have an open circle. Okay, and that's exactly right. So there's an open circle. And now this picture expresses this set builder notation. Okay. Now, another way to express this interval is the union of the sets negative infinity 0, 0, infinity. Okay, this is set notation. This is set builder notation. Okay, first of all, well, I'm gonna let you explain it, and then we'll modify it if you don't give me a good, totally correct explanation. But so far, you're pretty much on a roll. Okay, so here's another notation, and I asked, well, we see notation like this, and I got the answer, yeah. Well, what's this thing mean? And the answer I got was union. Okay. Now, I'll say a little more about it, but I'm not having to say too much because again, everybody seems to be well familiar with this. Okay, first of all, I had the question a minute ago, what's an open parenthesis mean versus a closed bracket? Okay. Well, it means that 0 isn't included. 0 can't be included here because it's this set, and the condition on this set, the only condition is that X can't be 0. All right, well, that's pretty much everything that I need to say about this. The union means X is in this set as long as it's either in here or here. It can't be in both because they don't intersect. In other words, because there are no numbers between 0 and infinity, that would be on this side of the 0, and between negative infinity and 0, which would be on this side. So we call that disjoint sets. Right? It could be here or here. If it's here, it's in the set. If it's here, it's in the set.